Now our lymph nodes, lymph nodules, okay, they are not lymph nodes, okay? Okay, they are the lymphatic tissue without a capsule, okay? And as a result, they are more scattered, okay, around in the body. And together with the regions of the lymph nodules, not only in the digestive tracts, for instance, your tonsils, they are called the mucosa associated lymphatic tissue, or moat. So in a good example of it, you probably can have experience with your tonsils. For instance, if you're getting a cold or an infection, your tonsils are going to swell up. Okay, so they're fighting the pathogens inside, for instance. And once they are much better, they will return back to their normal size and shape. So tonsillitis is what we call an infection, okay, or inflammation of the tonsils. And luckily, with recent help of medicines, you probably don't really have to remove your tonsils as before. Yeah. So take good care of your body and be very careful for swollen tonsils. Now, our development of our lymphatic tissue start from our mesoderm, and it will develop into, for instance, developing veins, and sections of them uh, develop into our lymphatic tissues. And your textbook will tell you more, but we'll leave it at the mesoderm. Now, next is our defense system. We're going to take a look at our immunity now. So we separate that into those you are naturally born with, innate response. These are what we call non-specific. Okay, because, example, like our epidermis region, part of our skin serve as a good barrier to fight off any pathogens. Now, adaptive are the acquired ones, meaning they are very specific. That means a certain immune cells are being challenged to, for instance, work with or capture a specific pathogen. Okay? And we'll take a look at what they are in the next video lecture. Now, so they split into the cell-mediated ones. These are regarding one type of your T cells that carry out, and they will really kill the pathogens. Antibody-mediated one refers to a type of B cells. For instance, they are the ones synthesizing antibodies. Now, first, let's take a look at our first line of defense, as well as the barriers. So our epithelial layer, which is the great barrier. Okay? This is very important to fight off any foreign pathogens or viral particles. Now, if you have an open cut in the skin where you go into the ocean or a la White Canal, make sure you don't, because the pathogens and microbes will find their way through the open sore and get into your system. So don't do that at all. Yeah. Now, tears contain something very special. So let me give you two choices: lysosome or lysozyme. They have one of them. Think about it. Right, the lysosome. If you pick lysosome, it's unfortunately the wrong choice. It's an organelle. Okay, remember back in our cell, this was a long time ago, but this is an organelle that acts as a little stomach, lots of enzymes in there to help you degrade and digest stuff. Now, what tears have? They have the lysozyme. So this is an enzyme to break down certain cell walls of the bacteria. Okay, so next time if you're crying, don't be embarrassed. Have a good wipe. Spread those lysosomes around. And I also told my 6-year-old son Taka that if your eyes are feeling itchy, don't rub it in. Okay, you should actually, a better way is to cry. And if you have a hard time crying, maybe you should yarn. At least that will get some of the tears out. Our gastric juice, also very powerful first line of defense. We say this is very acidic. So would the pH be at 11 to 13 or pH 1 to 3? It's 1 to 3. Yeah. If you have pH that's 11 to 13, you're gonna come see me because we're gonna go to the doctors. You'll become famous, and I'll become famous as the person who discovered you. So this, when you have pH of 1 to 3, it's very, very acidic. Okay, so lots of acids in the form of protons. So any microbes that are in here, hopefully they will be degraded. But you'll probably find out there is some that actually enjoy living in acidic condition, and we'll see that next time. Now the urine is a way to clean out the microbes in the urethra. And both vomiting as well as defecation expel microbes as well. Okay, so here is a summary, and make sure you can describe them. Now our second line of defense, okay, relates more to the inner cells as well as substance that you produce inside your body. We make several of these that count as antimicrobial substances, such as interferon. They are synthesized to inhibit viral replication. We also have the complement system. We'll see more of them later on, but what it does, imagine this is a cell. These are cells that are infected with pathogens. So what the complement system will do is they have lots of protein that come together and they form a pore. As a result, do you think contents can leak outside? The fluids can enter into the cell? Yep, you bet. So eventually the cell will undergo lysis and they will die. Now, iron binding proteins, for instance, like transferrin, they also have their way of inhibit certain growth of bacteria. And our antimicrobial proteins have their way as well to inhibit microbes. Okay. Now, natural killer cells work really by killing the cells, infected cells. So they will secrete, for instance, structures similar to the pore, as well as release enzymes to break the cells down, break the contents inside. We also have phagocytes. We'll see it in a moment that phagocytize the microbes or foreign pathogens and degrade it. Now, our inflammation is a very strong response to help fight off pathogens in a site of injury. Fever is a very interesting way. Now, our normal body temperature is 98.6 degrees Fahrenheit or about 37 degrees Celsius. Now, when you have development of fever, in most conditions up to 104, you would still be considered okay. So this is about. But if it's too high, you have to be very, very careful because this is my diagram of a protein. Now, does your protein work well under high heat? So think of, any one of you fried eggs recently from a raw egg? Right, so imagine your raw egg there, the protein look like this, very gooey. But if you put it under high heat, this is your frying pan and this is your egg. After it's cooked, it's whitish, it's not gooey anymore. This is called denatured. So your proteins are denatured. They are not in their favorite condition. They like to be in colder condition, yeah. So when they're under high heat, they are cooked, they are denatured. So as a result, imagine inside the cells, your enzymes are under high heat condition. They're going to unfold and become denatured, then they cannot carry out their functions. And if it's a transport protein, they can't carry out their function as well. So you have to be very, very careful of high fever, okay, Don't let the fever go too high. Now, phagocytosis are carried out by our neutrophil and our good old friend macrophages. Okay? So first of all, they will go to the site of the microbes because lots of molecules are released and will sense that as chemotaxis. So imagine if this is a piece of candy and this is my 6-year-old son, boy, he will see it in 2 seconds. So that's a form of chemotaxis. Now also, the second step is binding to the microbes using the pseudopod and then taking it in through ingestion. Now you will see the phagosome will combine with the lysosome. So here is that little stomach in the organelle and the cell, and they have digested enzyme that break everything down and eventually killing the microbes. Also, our inflammation a very powerful way to help us fight off infection. So anytime you have inflammation at the site of injury, you will probably feel the heat. It's getting more reddish. The whole place is swelling, and if you touch it, even without touching it, you probably will feel the pain. So what happened here is, and if you have a site of injury like this, a tear in the skin region, vasodilation will kick in. This means dilation of the blood vessel into a larger one. So more blood will rush to this region. So as a result, you see swelling, you see the redness as well. Now the second thing that has to happen, you have increased permeability. Okay, so as a result, the blood cells that need to, oh, not the blood cells, sorry, the cells like the phagocytes will be able to get to where they need to go. So histamine is released to help with vasodilation. Now you also will see prostaglandin as well as a leukotriene that helps with increasing of the permeability of the endothelial cells. As a result, the phagocytes can go to where they need to go and start taking away, ingesting, and fighting off the pathogens. Ultimately, the tissue will repair, your fibroblasts will keep on making new collagens and to seal up the regions over here. And a lot of times you might see the formation of dead cells and fluids and the formation of pus. Yeah? So here is the summary of that. Make sure you can describe them well as well. And we'll see you in the next video lecture.